Hello, everyone. Thank you for joining. After a whole day of listening to deep dive on codes, probably this might be an interesting talk for a few of you. It doesn't have a single line of Rust code, but it's all about Rust. So please bear with me through the end. It's about the humans who are contributing to Rust ecosystem and the projects. And it's just my passion project. I wanted to explore it further. A little bit about me. I am a research engineer at UBC. It's a university in British Columbia in Canada. And I'm also a community lead for Rust India. And I have been at multiple places before, worked for the Rust Foundation as a fellow. And I worked for a startup called Fermion doing WebAssembly stuff and a bunch of open source other projects. You can find me at tiru.tech. And that's me with a wallaby. I thought it was a kangaroo when I took the photo. And yeah, the main goal of the talk is, or the project is, knowing more about the people who are contributing. We have seen all the 6-week release cycles, and we expect the code to come as if it's being shipped by elves in like the poles or something. But these are people volunteering and contributing from different parts of the world, and they're somehow doing it. And this kind of project kind of sees the ecosystem in a much higher level view and see where we can focus our efforts on. Can you hear me? Okay, yeah. So to analyze it, we actually need a very high quality data set. And this required a bunch of steps. The first step was to collect a pretty predetermined set of data. It is a 1-year commit history of top 3 Rust projects, the Rust compiler, Rust analyzer, and cargo projects. Just by amount of stars that they have, and I have excluded MDBook and Rustlinks just because they're training projects. And I have taken basically the pull request data and I have enriched it with the authors and the reviewers, and based on the public GitHub data, I have taken their location, full name, and other stuff. And after that, I removed the bots from it, like RustBot and other things, which I think is the #1 contributor in Rust contributors. So to not have any skewed perception, remove all the bots from the data. And on top of it, I have used multiple packages like Geography 3, which basically gives an ISO notation, which is a standard notation of a country, instead of whatever people put on their GitHub profile, which can be anything. And I have manually classified it further on top of it because the package was classifying US as Earth, which is not the case. And yeah, I have annotated ISO codes to make it more streamlined. And on top of that, I used 2 additional packages, which is Stanford Name Entity Recognition package, which basically tells if an account is a bot or a human name. And after that, I've used NameSir API, which is a NLP API to infer likely gender, which is really hard, from location and name, understand the cultural and the location, full name of the person, try to determine a likely gender. And at the end, I have built social graphs out of all this pull request data to see how the community is structured and how is there any patterns that we can see, or how it is, what we can learn from it. So there should be a base assumption before looking at the data, right? And the only base assumption I could make of is the annual Rust survey, which has been conducted by the community for quite a while, and it's the most reliable source to see community distribution. And this was 2023 survey results distribution that was published on Rust blog. And these are the community kind of distribution. The top 5 are like United States, Germany, China, United Kingdom, and France. But let's see what the data shows 1 year prior to this survey, when this survey was released. to see who are the actual contributors. And first question is, where is Rust being built? Is it in, I don't know, is it in the only top 5 countries that we have seen so far? So this is the kind of bar chart distribution of how many people, or what's the proportion of people from each country that are contributing across projects, top 5 projects, top 5 countries per project. And I had to group all the countries together to kind of make their own presence in these graphs. And basically, it has 2 components. One is the contribution share, which tells how much are people from certain country contributing out of all the contributions or pull requests or reviews. And contributor share basically tells how many people from that country are contributing. And here, basically, we can see that few countries pop out like Romania, Iran, and Taiwan, which we kind of don't see in the community survey. And they are basically, I think, very few people who are like maintainers or someone who are kind of contributing to these projects. And this is one anomaly from the survey results I've seen. And I wanted to take it one step further. That's why all the data enrichment to see the likely gender and membership status. So this is the gender distribution of all the projects in the Rust, at least the top 3 projects in the Rust ecosystem. I also wanted to see that across projects, because each project requires different domain expertise. And Rust project, and overall, there's a really like low women or other participation, and it's disproportionately men. And these are, again, in proportion to each country. And for example, in Iran, there was only like 1 contributor. I couldn't find their gender, so it's not known. But yeah, this is one interesting observation. But more interesting one was this one, it is about membership of Rust GitHub organization, which is like if you look at GitHub memberships, it's a kind of an equity for contributors who are spending so much time. Here you can see like in Rust Analyzer project or in Cargo project, there are these are like top 4, top 5 contributors from these countries who are contributing to these projects, but they don't have GitHub membership status or like some kind of equity when they're contributing. This was kind of some kind of a dark pattern that I observed. And now coming to the, that was just all the pure data that I have seen. And now moving on to the social networks, I have built 2 types of networks. One is using directed graphs, another is using undirected graphs. But in the basis is like there is an author of a pull request and there is a reviewer of a pull request, and the edge kind of goes from an author to a reviewer, showing a pull request merge process. And undirected graph, there is no direction. It's just an interaction between 2 nodes. The directed graph tells us if there is some kind of reciprocity between 2 nodes, and also it gives us kind of influential nodes in a network. And undirected graphs gives us more the community structure overall and how it is grouped together. We'll see that in a moment. So how are the communities structured? I just wanted to see from a top-level view, based on the contributions, how the community is structured. Is there any hierarchy between few contributors, or is there members density, or like non-members, or some geographical density, or some gender density, or something like that that we can see from the data? And this is for the Rust project. It's really huge. There are a lot of contributors, so it's hard to tell from here. But the main thing are, the colors are pretty, but they don't mean anything. The main thing to look at is the circle means non-member of a GitHub organization, and square with M is a member of a GitHub organization, of the Rust GitHub organization. And mostly members are kind of centered, are concentrated in the center, whereas non-members are kind of distributed around them. And there's also like a tiny island that you see on top, which shows like there are non-contributors who are, non-members who are kind of merging PRs to the project on their own without a member being involved. It's the same in Rust Analyzer project. It's much smaller, but we can see like members are kind of concentrated in the center, and non-members are around and distributed. And the same again in cargo project as well. It's just all these graphs are built using a community detection algorithm called Levine algorithm. It basically uses a greedy method to form these colorful circles to see who are kind of interacting among themselves. And it's good to see their like member, non-member kind of subcommunities formed, and only non-member communities subcommunities formed. That it sounds that the project is sustainable and it's being kind of contributed by all sorts of people. And this is just visual description. We also can see some metrics, graph metrics, to understand how the projects are kind of how the social networks are kind of structured. And the first metric is reciprocity. Like I mentioned before, it's how much of a like if one person is contributing a pull request, and how much is the reviewer giving back to that contributor, or is it only one person who's doing all the reviews and other person, rest of them are kind of contributing to it. So mostly Rust and Rust Analyzer have very low reciprocity. Rust Analyzer has the lowest, which shows that there are very few people who are doing almost all the reviews. This shows that it can easily lead to burnout. And the Cargo project does it better. It has a little higher reciprocity here. The second interesting thing is density, to see if these real-world networks have any density, or are there any member-dense subcommunities formed, or are there any country-specific density subcommunities formed, to see any dark patterns. And overall, they're very sparse networks, so there's not much density formed, and it's a good thing to see. The last, this is another interesting metric I've seen, is to measure a group's diversity quantitatively. I've used this formula. It's called Blouse index. Basically, like if in a room if there are 10 people and they're from same country, the Blouse index would be 0. But if they are from multiple countries, it will be higher, indicating there's diversity. Since I have formed all these sub-communities in Rust and Rust Analyzer and Cargo project, I wanted to see how diverse they are. And overall, they're pretty diverse geographically. The 0.00 community aid that you see is basically 2 people subcommunity, and that doesn't count. But in general, it is pretty diverse. And other important thing is to see who are the most influential people in these graphs that you have formed. This can be measured using centrality scores in graphs. Basically, I've used 3 centrality scores. First one is called degree centrality. It's pretty basic. It's how many edges does a node connect to. And it gets interesting because I have the demographic information, where they're from, and likely gender, and are they member of GitHub organization. And as you can see, the first 2, these are the top 5 contributors from each project as per this metric. So in Rust Analyzer and Cargo project, there are the top 2 people have like disproportionately high degree centrality compared to rest of them. And betweenness is another centrality score. It's basically telling how many edges go through a particular node. And here, again, in Rust Analyzer and Cargo project, the first 2 contributors kind of have really high betweenness scores, but the next 3 are kind of really low, if you can observe. And again, not many have membership stake who are really influential people in the community as per this metric. And the last one is eigenvector centrality. It basically tells what are the nodes that are popular among popular nodes that are connected to popular nodes, popularity among popular nodes. And here in Cargo project, the top 2 nodes or people kind of have really high eigenvector centrality compared to rest 3. Again, it shows like the concentration is between very few people in the project. And you must be thinking by now, like this talk could have been an email or like a blog or something. Uh, it is a research paper, so if you're interested, please do read it. Later on, I'll share the slides. I have, there's like clear methodology and what is like citations to see more. And there's, of course, a lot of limitations in this study. The location is self-reported by a user. It can be anything, and it doesn't represent nationality. And the gender inferred is very limited to the API and the packages that we have used. And there's also technical factors. I have removed self loops. There were a lot of self loops in these graphs, basically someone merging their own pull request. I just wanted to see collaboration between two nodes, not just one person doing their own merging process. And it's very limited data uh, specific to 2022 till 2023 when Rust uh, survey was kind of released. And there is no qualitative input in this study. It's purely quantitative. I wanted to stick to only the data and see what the data shows. But that doesn't tell the whole picture. The qualitative and the humans behind, like who are maintaining it for years, might have been doing it. And this is just what the data shows. Future work, it would be really nice if this work can be extended to multiple communities in JavaScript ecosystem or Python ecosystem. And I also wanted to do a longitudinal study where this can be done in a span of 10 years instead of 1 year to see like what are the contributor patterns, did they drop out for some reason, who are core members of the project, or was it, and add some qualitative work to it so we know the reasons, like what were the reasons. Was it burnout, or was it some other reason, or was it something else? Just so that the community has all the information to make the best decision. So I have mentioned everything. This was like the research part of it, what is done and what can be done. But what is being done right now is also interesting. The first thing would be, if you haven't seen, there's a effort being done by the core members. It's called Rust Vision Document. It's been there was a talk at Rust Week in Netherlands where they talked about how they're kind of trying their best to take inputs from multiple people across the world and across different expertise of Rust, from like very beginner to very expert, and across different domains and industries and regions. It's a multi-people team who are kind of leading this effort. It's really cool. I have added the links and the RFC process that has been accepted. It basically focuses on the next 3 to 5 years effort for the Rust project. I was lucky enough to be part of this particular pull request. It is basically syncing the membership of GitHub organization. This basically updates the membership status in GitHub for Rust repo. So all the new contributors who are contributing will get access to Rust membership on GitHub, and people who have not been are actually shown in this blog post, and they also get an intimation before being removed. So new people are getting some equity when they're contributing to the project and get some kind of inclusivity. And there's also other things done by the foundation, like community grants program. They also offer some compute for contributing, so it's accessible to people, and they're not limited by their hardware. And there's also like Rust Foundation fellowship programs and multiple other initiatives taken by the community, which are really interesting. The last one is, this is the second year Rust has been accepted through the Google Summer of Code project. This is kind of a mentorship approach that the community is taking to mentor new and upcoming talent and students to do the community and welcome them through kind of some mentorship, and which leads to a successful contribution to the project. And yeah, that was like pretty much it about what I wanted to cover overall. I wanted to show my talk and what is being done. This talk is mostly a dialogue starter and kind of something for the community to think about. It is one of the first quantitative studies on the community. Mostly the leadership team has been working on qualitative approach by taking surveys, input, interviews, and everything. But this is one, and hopefully there will be many. And you can reach out to me on LinkedIn or my email if you have questions. But thank you very much. And yeah.